Today, we've got a healthy agenda, starting with introduction of Bitmovin and Zixi, an architecture overview, example of Zixi and Bitmovin workflow, a case study, some common myths, takeaways, and then we'd like your questions. So during the presentation, please be entering questions into the Q&A tab, and we will try to answer as many as we can. If we're unable to answer all of them, we have a record of your questions and we'll respond to each of them by email. In the poll section, we also have a question of how you'd like to be contacted after this. So please put that information in as well. And so to get started, we'll turn it over to Sean for an introduction to Bitmovin.
Thanks, John. I appreciate the introduction. We can jump to the next slide. And many of you may already be familiar with Bitmovin, so I'll keep the introduction rather short. Bitmovin is one of the world's leading video technology companies, powering some of the largest broadcasters in the world, such as the BBC and some of the other logos you see here on this slide. We were founded in Austria out of university research by our two brave and fearless leaders pictured here. Their research helped to actually establish MPEG-Dash, the ABR protocol, which is now an industry standard. We were first to market with a commercial Dash player and have since been awarded 11 US patents and recently announced a joint research program with the University of Klagenfurt to continue R&D and innovation in the space. We're currently focusing our efforts on 3 value drivers or needs that we see in the industry, and we can jump to the next slide and explore those. So here we're displaying our 3 value drivers or trends that are really driving innovation in the space. For the purpose of today's discussion, we'll focus on the first 2 value drivers, increasing quality of the viewing experience and getting content to market faster. When we discuss improving video quality, we really mean everything from perceptual quality, which may come as a result of fine-tuning codecs, to QoS playback, assuring 5 nines uptime and reliability. For faster time to market, this means helping launch apps as quickly as possible on as many devices as possible. With the OTT wars in full swing, it's really essential to have timely launches, and we remove a lot of the complexities associated with that. We're also referring to the time it takes to turn around assets and have them viewable by your audience before a competitor does. In today's digital age, it's really a race for publishers to release content in order to maintain viewership. And for operational optimization, we're really talking about tackling the overall economics and total cost of ownership associated with streaming workflows, as well as being aware of what's happening, how your content is performing, and how your viewers are engaging. And we can jump to the next slide. So we address the 3 value drivers through our 3 core products. They're each highlighted here, and many of us know us for our cloud native encoding or our cross-platform player. Some of you might be unaware of our latest product, which is analytics. It's a streaming analytics SDK that's completely decoupled from our player, so it can be integrated into any player. We like to emphasize the developer-focused nature of our products. So these are all API-driven and offer well-documented multi-language SDKs. Because this is a joint webinar with Zixi, we're going to focus primarily on our encoding product. We've integrated the Zixi broadcaster to accept Zixi signal acquisition, and we'll dive into the weeds a little bit about exploring the value props associated with that. And we'll discuss our encoder's core features, how it can be used and deployed in a live workflow. So let's take a look at some of the customers who are actually using our products. So a showcase of our customers can be seen here. This is just a taste of some of the brands we work with: BBC, ClassPass, New York Times, Fubo TV. These logos, along with many other well-known broadcasters, are using at least one of our products to address their business needs. And I'd really like to highlight Fubo TV here specifically, as we work pretty closely with them on our Zixi integration. and actually first implemented Zixi as an encoding requirement to meet their needs. So they actually were a driving force that kind of brought the two companies together. And I guess this is a good time to hand it off to Tim to explain a little bit more about Zixi and where their products fit into the workflow.
Okay, thank you, Sean. We can go to the next slide and we'll dive into the background of Zixi. So Zixi provides cloud-based and on-premise software-defined video platform that transports broadcast live video over all IP and hybrid networks. This enables our customers to provision and manage and deploy over 10,000 live linear channels, as well as live events. Zixi supports all major protocols, and it's used around the world by broadcasters, OTT providers, and service providers in over 100 countries with 50,000 active devices. Video transport and delivery over IP is doing to broadcast infrastructure what cloud computing did to compute infrastructure. It's enabling broadcasters to do things at scale that wasn't possible even 2 years ago in the broadcast world. It also allows them to save money, allows them to be more flexible and nimble, allows them to connect to places they can't normally get to or were previously cost prohibitive. Okay, let's go to the next slide. At Zixi, we have over 170 partners and OEMs, so almost every device and almost every service provider out there in the broadcast world has Zixi integrated into it, either in its services or integrated into its hardware. This includes Bitmovin, who we're here with today. We see highlighted there on the slide. Zixi has native deployments on the largest cloud platforms and is used by most of the OTT platforms and many of the premier content owners. As of this call, the Zixi-enabled network, which provides you with the interoperability and the ability to future-proof the workflow decisions you're making today. Next slide. Broadcast quality live video contribution and transport and delivery over IP is the core problem Zixi is solving for our clients. And we do this by bringing hardware and software and cloud solutions all under one platform. Zixi has built and assembled a software-defined video platform consisting of a tight integration of 4 crucial elements, which we see listed here. First are the protocols. This includes the time-tested Zixi protocol, which has been in mission-critical use for a decade now, as well as newer protocols such as RIST and SRT, and common industry protocols that we're all familiar with, such as RTP and RTMP, HLS, and DASH. In total, we support 15 different protocols. The second major component is the Zixi Video Solution Stack, which is the software, the brains that manages all the protocols and collects analytics and layers intelligence on top of the protocols for things such as bonding or hitless failover. The third component is our control plane, which is ZenMaster. And ZenMaster allows you to intelligently provision and deploy and manage and monitor thousands of content channels across your Zixi-enabled network. And finally, which we mentioned in a previous slide with our partners, is all the Zixi-enabled devices around the world. And we call this our Zixi-enabled network. Let's go to the next slide. Here we're showing a variety of applications and use cases that we see and we work with our customers on a daily basis. One of those is customers moving off of satellite, which has high fixed costs, to a more flexible infrastructure. Another is customers that need to exchange and syndicate linear video content with their partners with less complexity. We also have customers needing to orchestrate and manage hundreds or thousands of individual linear channels. Customers are looking for new ways to monetize their linear content. And relevant to our discussion today, our partnership with Bitmovin is an example of allowing customers to move their linear workflows to the cloud and virtualized infrastructure. So now let's look at the Bitmovin integration in a little more detail. We'll just start with the visual and then we'll go into more details over the next few slides. In short, Bitmovin has integrated the Zixi broadcaster software into their cloud-based transcoding solution so they can acquire Zixi streams from any source that produces Zixi streams. Okay, next slide. As we saw in the previous slide, our joint customers with Bitmovin are using the Zixi protocol for signal acquisition or live video contribution over IP. But before we go into the details of that, I want to talk about the the traditional approaches for contributing live streams over IP, and then we'll talk about the Zixi approach. For many years, the protocol, the go-to protocol was RTMP, a semi-proprietary protocol from Adobe. RTMP, sitting on top of TCP/IP, has been implemented in every baseband encoder under the sun, and works reasonably well under ideal network conditions, meaning no packet loss and minimal jitter. To accommodate the limitations of the protocol, however, if you are traveling large distances, CDNs and other services that ingest RTMP would place servers at key geographical locations around the globe, so they would be near or close to a majority of the contribution streams. So by being near or close to it, then you would have less packet loss and jitter. This approach can be expensive and difficult to maintain. RTMP is also limited to a single channel of video and only 2 audio channels, which might be fine for basic live streams, but your broadcast quality content typically requires more video channels and definitely more audio channels to support multiple languages. Upon introducing the HLS protocol and the emergence of the Dash protocol, these 2 formats also became viable alternatives to RTMP for contribution. However, because they're they're based on file transfer of segments of video, there's an inherent latency penalty. There are more recent developments, such as CMAF chunk transfer approaches for low latency HLS and Dash that can help reduce this latency. But then you're back to the same situation you had with RTMP, which is HLS and Dash sit on TCP/IP, and TCP/IP is not very robust for real-time delivery under non-ideal network conditions. So this brings us to the Zixi protocol. And really, the Zixi protocol is a result of Zixi working with major media and broadcast customers for the last 10 years. It sits on top of UDP, and its robustness under high packet loss and high jitter network conditions comes from the algorithms that we've developed and fine-tuned, over that time working, with these customers. Some of the key things to note about the Zixi protocol is it's distance agnostic. So you no longer have to locate your ingest server, near where you're contributing from. The Zixi protocol is going to take care of any of the packet loss and jitter that you have, even if you're sending a contribution stream from India to North America. That's fine. It addresses packet loss and jitter with congestion-aware ARC and FEC technology. Bonding and hitless failover are implemented to make use of multiple network paths. So from a reliability standpoint, you want to be able to have multiple contribution paths coming from your source through diverse networks, and then be able to do hitless failover between those. The Zixi protocol can use basically any IP, any IP network that can support UDP. So this could be public internet, which we're all aware of. It could be the low orbit satellite IP networks that are starting to come to fruition as the low orbit satellites are being put in space. Of course, 5G and 4G and fiber, any type of IP network. The Zixi protocol also supports multi-program transport stream. So this means you can have multiple video sources in the transport. You can have many audio channels, and of course things like SCSI 35 for ad insertion or captioning. All of those things are supported in the transport stream. And finally, with Zixi, the streams are secure both with AES content encryption as well as DTLS session-based encryption from the originating side to the receiving side. Okay, let's hit the next slide.
I wanted to just chime in on that previous slide for a second, Tim.
Sure.
Yeah, two anecdotes just from my previous life at Akamai in sort of supporting live streams on the server side, as well as what we see on the encoding side. From the traditional approaches, CDN and these CDNs and ingest networks, although they have these they have their geo-dispersed servers everywhere close to end users, they don't want to build out, RTMP servers or, put Flash software on their servers to accept those anymore. A lot of the major CDNs are actually end of lifing, RTMP ingest. And it was great for, 1 bit rate, but it really wasn't ideal for multi-bit rate. And then on the HLS and Dash side, it's great. But that first mile is an extremely, there's a lot of instability there. And it might not even just be on, pure timeouts, but everything from additional BGP hops on the first mile really offer, instability and disconnections from the edge, and weird mapping from time to time. So I mean, having seen, Zixi used an input on the CDN side, it really does, these sorts of protocols really do help with, reliability and resiliency. And then even on the encoding side, when we acquire a lot of these signals, we're not, although we're in, multi-cloud, we're not always coexisting with, source content. So oftentimes it's that same instability of the first, the open internet on the first mile. So we actually really prefer a stable protocol, whether it's, an SRT or a Zixi, to really make sure we don't get the whole garbage in, garbage out scenario. We want a strong signal acquisition for processing. And I don't mean to take over your slide there, but I just want to reiterate that it really does, make a difference from our side as well.
Yeah, that's great. From, you definitely had the experience from this on the CDN side of RTMP ingest and the challenges there. Yep, thanks. So let's talk a little bit about typical contribution scenarios of, live video over IP. Of course, live events come to mind when you think about contributing live video from an event location. The Zixi-enabled encoders and video cameras and mobile apps can be used to contribute video from that event location. Here I just show, some examples of hardware that's out there. Alternatively, any on-premise encoder or a local production switcher can be used with standalone Zixi feeder software, where the Zixi feeders is there on the local network. So you produce your event locally and then send it to the Zixi feeder locally, and then the Zixi feeder sends it up over the public internet to the receiving side. What may not be as obvious to everyone in terms of IP contribution scenarios are the huge numbers of linear and live linear channels around the world that ultimately need to be transcoded and packaged before being delivered to viewers. So many content owners and aggregators are already managing this content with Zixi software and can provide Zixi feeds for these channels. So there's already thousands of channels out there, linear channels where there's already Zixi feeds available for those, that an OTT service like a Fubo, which we'll talk about in a bit, can get access to those Zixi feeds and then turn around and provide that to their subscribers. We also see AWS Media Connect, which ingests and delivers Zixi protocol streams, being used more and more for both live events and for linear. And so any content today that's flowing through Media Connect is another source of Zixi streams that that ultimately would need to be transcoded and packaged before sending out to the viewing audience. Okay, let's jump to the next slide.
Cool. Yeah, thanks, Tim. I could take this Yep. one. So a lot of our encoder features, and really here we're just diving into how our encoders use some of the value props as well as our player, and our Zixi integration. So I think Tim did a pretty good job, explaining the value props associated with Zixi. So I won't really dive into the weeds there. Other than basically we did integrate their broadcaster as at first sort of a statement of work for one of our customers, but it's been reused since. It was a really good integration. Now it's just sort of an out of the box feature. We support the Zixi broadcaster for the signal acquisition, but looking at our encoders specifically, a lot of our encoders features are typically leveraged in a VOD workflow, which makes sense given the cloud nature of the product. In traditional broadcast scenarios, live production usually requires on-prem hardware, and the cloud is seen as an additional layer of complexity, which also introduces latency. However, with OTT, it's becoming more and more acceptable, in some cases actually preferred to run in the cloud, to run transcoding in the cloud. So one good thing about our encoder software is whether you're doing a VOD or a live encode, you're actually running the same software and service. So a lot of the same features can be used. Of course, you won't be able to leverage 3-pass or per title technology or some, VOD specific technologies. But there are a lot of, key features for live workflows that we support. Of course, real-time live encoding is a given, but a real differentiator is our codec support. We were first to market with AV1 and a live encoder, and actually demoed a 4K live AV1 stream at NAB in 2018. We also offer a host of other next-gen codecs like VP9 and HEVC, and all of the codecs that are supported in our VOD software. For 4K cloud workflows, we're actually a strongly preferred vendor, and we see a lot of business, a lot of business being driven specifically for that need. Most 4K encodes depend on proprietary hardware and ASIC systems. Most can't leverage their full feature set when they're decoupled from the underlying hardware and just containerized and deployed as a VM. Elemental is a perfect example of this. Even in their own cloud, in Amazon's cloud, they're not able to get 4K or 8K encodes in either live or VOD because their dependency on GPUs. We don't have that dependency. Our software native solution can support high resolutions, high frame rates, more complex codecs in both live and VOD. And, of course, we support chunk transfer encoding, which is an essential piece of the low latency puzzle. We have SaaS offerings in all the major clouds and offer licensed software, which can be deployed on-prem or in a customer's VPC. Sometimes we see customers want complete control, either for security reasons, or perhaps they've negotiated better deals with their cloud vendors and can run very cheaply. So that's always a useful option. You won't get that with some of the other vendors that will lock you into a particular cloud. On top of the Zixi hitless failover, we actually support our own seamless failover capabilities, which keep frames in buffer for frame accurate A/B failover. Our live to VOD functionality makes it really easy to clip VOD assets from a live stream and send the manifest directly to storage. So it's usually a less complex way of creating these VOD derivatives when compared to the same features offered by CDNs. And if you're in a multi-CDN world, that might become tough, or if you're hosting your own origin, that might become tough. So doing it on the encoder side makes a lot of sense a lot of the time. And we support all the major output protocols and formats. So, obviously the HLS, Dash, and Smooth, but also, Akamai MSL, Unified Streaming are all supported outputs for live. On the player side, we list a few value props here, but an additional key differentiator is our custom code base. So we don't build our player on top of open source projects like Dash.js or HLS.js. We leverage device native SDKs whenever possible. We're not just deploying, an HTML5 player. And we see a lot of, I think, business because of that, because of our stability, our feature parity across devices, our ability to reach all devices. Now, I guess, since we understand the use case and value of our products, let's take a look at some of the customers, at one of the customers who have deployed a Bitmovin and Zixi solution. So here we see Fubo TV. We're going to dive a little bit into their workflow and a little background about them. For those who aren't familiar with Fubo, they're a service known primarily for live sports distribution over the top. However, they do offer a lot more than just sports. They're essentially a subscription-based, bundled cable type offering with over 100 live linear channels. They're a subscription-based service. They're strictly delivering OTT, which makes their workflow somewhat unique compared to other, linear playout systems or services. Traditional broadcasters, aggregators, and linear playout facilities usually operate with cable, satellite, or terrestrial distribution in mind as well. They're strictly OTT, built a cloud native solution from the ground up. They've been running on in the cloud, and we'll dive a little bit into their workflow. But Bitmovin is working with them on encoding a subset of their channels, as well as providing a cross-platform player. So we're currently encoding 11 linear channels for them, including premium channels like Showtime. And we could jump to the next slide and dive in, into what some of their requirements were. I guess, Tim, if you want to just...
I can start off on the acquisition side. Yeah, like Sean mentioned, so Fubo has a premium subscription-based OTT service, and they actually have expanded, far beyond sports, live sports, even though that's where they started and got their name. So they needed to be able to acquire linear content from content owners. So this may be an NBC Universal, or also from content aggregators. So this might be someone like a Comcast Technology Solutions or Encompass Digital Media. And so they need to be able to ingest that content, and then they need to be able to transcode and package it for their subscribers. So to receive that linear content from the content owners, they're pulling in Zixi streams and taking advantage, of course, of the resiliency and security of the Zixi protocol. And then they do their own processing, which they're also doing in the cloud. Fubo is very much a cloud first type operation. And then they feed the content to Bitmovin via Zixi streams as well. Sean, maybe you can dive into the specific encoding requirements they had.
Right, thanks. So the encoding requirements were pretty straightforward. Once we implemented the Zixi broadcaster, most of their other requirements required minimal integration, and were pretty much out of the box features in our encoder. The need for a multi-cloud AWS GCP setup was kind of unique, and it came primarily from the need for resiliency, as well as a specific requirement to run certain channels on GCP exclusively. Those channels use Google Cloud Storage for VOD assets, and Fubo needed the ability to leverage live to VOD features for this subset of channels. And that feature, like we previously stated, is basically intended to clip a VOD asset from a live stream with one simple API call, providing start time and end time. The encoder will generate a VOD manifest, just referencing a subset of segments, and post it to storage. But because the VOD assets needed to be stored on GCP, it made it much easier to run the encoding in GCP as well, and as well as their live origin. So this was easy for us because we have SaaS offerings in all three of the major cloud vendors. So it was a matter of just running one in GCP, and then a mirrored one with different channels being acquired in AWS. And they did run in our SaaS offering, so they didn't deploy our licensed software. When we mentioned scalable here, what we really meant was the flexibility to spin up and down channels as needed and not have to worry about the compute resources being limited. That's something that's, I think, really important to just cloud native systems, or one of the value props for running in the cloud in general. We don't need to worry about being limited to one VM or one box. We can scale to the degree of the cloud. It was also important that they future-proofed their setup and tackle CDN storage and egress fees. They wanted to do that by leveraging next-gen codecs like VP9, and at the time, other vendors weren't offering this for live streams. They haven't deployed VP9 yet, but there is a plan to tackle it in the future. And for the DRM, they went with a commercial solution by DRM, the KeyOS solution. And we were already integrated with them on the client side and the encoder side. So it was a simple integration. It didn't require any custom effort. And during that whole process, it was really a shootout between us and a few other leading vendors, two namely. And the decision really came down to time to market and the flexibility of a multi-cloud deployment. Some of the other major vendors just couldn't meet that requirement, and we were pretty much ready to go out the gate once we integrated the Zixi broadcaster. On the player side, there were issues with their original player, which basically caused compatibility problems with when newer versions of Dash were released. So they were running on a legacy Adobe Primetime product, and essentially the issue there was that it was built upon some open source projects. It was built upon Dash.js, and when there were new versions of MPEG Dash released, the the open source community was kind of slow to supporting some of those, and the underlying code base couldn't handle some of the features they wanted to leverage. That wasn't an issue with us, and we are doing their HTML5 player and are considering, tackling other devices as well. So we can probably jump to the next slide and look at their workflow in more depth.
Sure, I can jump into this. So we just wanted to help you visualize what the workflow looks like. We've heard about Fubo's requirements on the previous slide. So as we mentioned, Fubo receives contribution feeds from content owners and aggregators, and then they do their own processing, and then they send the streams to Bitmovin software on various cloud providers. And that's that reason is based on the workflow requirements that Sean mentioned. So in this workflow, both the ingest from the content owners and the delivery to Bitmovin, that linear content's traveling over the public internet, and between different cloud providers and in-house data centers at the content owners, and it's using the Zixi protocol. Fubo themselves, so they're running a Zixi broadcaster, so the Zixi broadcaster product, and so it's allowing them to both ingest content from the content owners, and then after Fubo does their local processing, then the Zixi broadcaster is used to send the Zixi streams over to Bitmovin, and on the Bitmovin side, there's a Zixi broadcaster there to receive those streams and then send them into the Bitmovin transcoding software. Yeah. After transcoding and packaging by Bitmovin, I believe Fubo's using Akamai for their CDN, and then as Sean just mentioned, they're using the Bitmovin player with that because it is built in-house by Bitmovin, they're able to quickly adapt to changes and standards and keep the player as modern as possible.
Right. And, from an encoding and playback standpoint, their workflow is pretty straightforward. There are two instances of our encoder running in the two different clouds, like you can see. And one issue we did run into pretty early on were irregularities in the incoming transport streams. So the way that, not the way Zixi was sending us the streams, but the issues with the underlying transport streams themselves, coming from the MX1s or iStream Planets, etc. It wasn't caused by Zixi, but they were sending us these sort of inconsistent transport streams, and basically that enabled us to do a lot of work on the stability side of our live encoder. Obviously in a 24/7 scenario, uptime and stability is very important. So we were able to fine tune our AB failover, which has been working great and seamlessly for Fubo. And it actually enabled us to work on not just stabilization, but other new features as well. So sometimes we would get sources with multiple audio channels that we weren't expecting, and they would come in different ways. Sometimes they would just be muxed in the segment. Other times they would be separate tracks in an HLS playlist. We were able to implement new features like multi-audio support, etc., which are now just sort of out of the box features in our encoder because of our early work with Fubo and Zixi. So I guess, we can tackle some myths, not just related to Fubo, but also related to just Zixi, Bitmovin, and implementing these sorts of technologies in general. Tim could tackle.
Sure. Let me dive in. Yeah, one example you just mentioned that is not specifically here, but you're talking about how the open source dash JS player, the community wasn't able to keep up with changes, as quickly as the standard was changing, and that's interesting, and kind of related to this first point, which is, the myth is, open source protocols are free, and better. It is true that from a do-it-yourself perspective, using open source libraries to build an in-house video delivery workflow can be really cost effective if you have the development resources. You can grab SRT libraries, or there are open source RISC libraries available as well now. You could grab those and build your own workflow. However, if you're using commercial media servers in your workflow, and these can be from a Zixi or a handful of other vendors, those media servers and their support and the feature development and enhancements for those solutions, that's not free. That's the thing. If you're using a commercial media servers to help make your workflow work, then that part of it is not free. Moving away from the DIY concept a little bit, for broadcast quality, you really need interoperability and resilience under difficult network conditions. That's what's going to make your workflows as successful as possible. For interoperability, what we've done on the Zixi side is through our partners, there are over 40 baseband encoders that natively support the Zixi protocol. This includes hardware appliances such as Elemental or Harmonic or a Tim, and even some smaller ones, and software encoders. This can be Wirecast or Livestream Studio or OBS or Gigcasters, and even some cameras such as JVC and Mevo. So all of these have the Zixi feeder natively integrated into that product. And as I mentioned before, even if you're using products that don't have the Zixi feeder natively integrated, you can always run the Zixi feeder standalone side by side. Overall, we have 170 partners that support the Zixi protocol for both on the contribution and delivery side, and a few media server like products. For resiliency, the Zixi protocol with its congestion aware FEC and ARQ is simply just the most mature, with 10 years of use and tuning, and is the most resilient under difficult conditions. And that comes with experience. It took a while to get the protocol as robust as it is, but that has paid off. However, in the spirit of interoperability, if protocols such as RISC or SRT or even RTP plus FEC are the only protocols available from content owners or aggregators, then our customers still need the ability to ingest those protocols, and the Zixi software supports all of them as well. So we recommend and promote the Zixi protocol to be used as much as possible and where possible. But we also understand, from our customers' perspective, if they need to be able to ingest streams that are in another protocol, we Zixi are going to give them a solution for that. And not, that's the right thing to do for our customers, and it helps make their workflows as seamless and smooth as possible. Sean, maybe you can jump into the next ones.
Yeah, and I don't know how much of a myth this first one is that people actually believe. If you do believe it, I can tell you you're wrong. Maintaining and optimizing quality is not easy for live. It's very difficult. I'd say more difficult than VOD for sure. And you don't have a lot of the same. You don't have the ability to risk a failed encode in a live scenario. You can't just restart it, and you can't use a lot of the optimization features that are available in VOD. So it's tough. Seamless failover obviously helps. So whether it's Zixi's hitless failover if you're using them for acquisition, or a solid A/B workflow with frame accurate switching between the two. Access to heavy compute resources really helps. Whether you want to scale up a service or scale down, you want a system that removes bottleneck from using additional resources. If you're sent, more complex frames, with varying GOP structures, et cetera, you need a system that won't crash due to lack of resources, and deploying in the cloud with a Bitmovin type solution is going to address that. Geo flexibility in live is huge. You don't want to be tied down to a one-to-one point-to-point type system. If you can use deploy on the East Coast as opposed to the West Coast, depending on where your source is coming from, that helps. We obviously mirror in different data centers depending on your cloud provider. So just in terms of reliability and stability from there, the cloud really is a more secure and stable setup than, point-to-point hardware. Quality optimizations, I think are huge. So whether it's deploying, an FFmpeg type solution, you don't want to leave your, encoding engineer or, just your software engineer who might not even be too familiar with the intricacies of encoding to really fine tune and optimize the codecs. I know with Fubo specifically, we spent a long time, our dev team sort of acted as an extension to theirs, and we really fine tuned both their bitrate stack. So, which bit rates we were producing, as well as the codecs themselves. And that's a headache that a lot of people just don't want to deal with, but, we sort of take pride in that. We have codec engineers that are actually developing the codecs themselves, so they know exactly when certain tools should be enabled or not. I mean, if you look at the number of tools that are available in just H.264, let alone some of these next gen codecs, it can be pretty daunting to know when to fine tune certain things. And we've done that. A lot of those fine tune optimizations are actually implemented out of the box now. We're very content aware type encoding. And so, these sorts of things help. But you're going to want to understand your streams, and that's difficult in live. Sources can change, complexity of content can change, but you're going to want to a system that basically allows you the flexibility to really fine tune things, and that's what our system does. Jumping on to the cost side of things, cloud transcoding is too expensive. That's a common misconception. It really does depend on the overall workflow and how you're calculating costs. So whether it's 24/7 or event-based is a big contributing factor. I mean, there's the whole CapEx versus OpEx scenario where, oftentimes for event-based streams that aren't running 24/7, it really does make sense to go with an OpEx model and to only pay for what you use rather than spending, tens of thousands of dollars or more on dedicated hardware that's being used, a fraction of the time. That one's pretty straightforward. But even in 24/7 live, in like a workflow like Fubo's, where your content already exists in the cloud, it's already being ingested to GCP, it's going to be delivered from the cloud out through CDNs, and there's really no need for baseband or worrying about baseband media or even hardware on-prem. It just makes sense to run in the cloud. You don't want the additional layer of complexity from taking content out of the cloud, processing it on-prem, and then putting it back up. You're going to risk quality and reliability issues, as well as probably increased costs, and the bandwidth usage would be extremely expensive. So sometimes it's just common sense that it makes sense. And then even when it comes to, controlling costs with our customers anyways, if we're looking at especially 24/7 workflows, but even event-based, if there's enough usage and we, sign on for more than one ARR, if we're talking 2-3 year commits, we can negotiate very appealing deals with our cloud vendors to really offset our costs, and we pass those cost savings on completely. Like we charge based on output minutes. So if our costs go down, we're going to pass those savings on to our customers, and that's more and more, I guess, doable if we can negotiate 2-3 year deals. And then, of course, we help our customers look at total cost of ownership. This is a big issue, I guess, that we've seen OTT platforms and service providers not focus on enough, though that's starting to change, and especially with the operational optimization value driver we're seeing in the industry. But basically not looking at a siloed view of encoding costs, but rather calculating your total cost of ownership from CDN egress fees, which is really, as your audience scales, that's the bulk majority of your costs. as well as storage costs, egress fees from storage, the maintenance of having to maintain players across all platforms. So we really help our customers calculate what their total cost of ownership is, and how, with the right targeted bitrate stack, the right codec implementations, both in terms of the codecs you're using and how those codecs are tuned, we can really offset a lot of those costs. And you might spend, in certain cases, a little bit more on encoding, but you'll see your total cost of ownership drastically drop. We have a few demos and some numbers on this, and on our website. Feel free to check them out. If you're interested in seeing how we can address your, the total cost of your workflow, we have basically a calculator that we've put together that has us input a few variables to quickly derive, a rough estimate of what the savings could look like. And, we do work very closely with our customers. Like I said, with Fubo as being an extension of their dev team, to really not just support the product, but to fine tune it and make sure that it's configured, optimally, and that they're leveraging, all of the features that they can be.
All right, thank you, Sean. And before we take a few questions, we'll quickly go over some of the takeaways. If anybody has any questions, please submit them now, and we'll try and answer as many as we can. Some of the things that we'd like you to remember coming out of this webinar is that with this integrated offering with Zixi, with Bitmovin, broadcast quality of service and quality of experience is possible. It's reliable. It's very reliable. It's high quality and can be achieved at scale with cloud-based solutions, not just on-prem. We enable efficient, agile operations. Moving from on-prem to software-based in the cloud means time to market and the ability to iterate very quickly. And we provide together economical, future-proof solutions. So you can customize configurations with the robust partner network that Zixi has, meaning you can use any device or service out of the 170 and growing Zixi-enabled network to get the resources that fit your needs. So, to some quick questions. The first one is, will this presentation be available to look back on? Yes, we will send it out to everybody that attended. And I'll note that with everybody working from home, there's some minor distractions with kids at home. So I think we can certainly all empathize with that at this point. Another question to Sean is, with the 8K live encoding, what is the latency for that, or do you use HEVC?
Yep. So HEVC, yes. We support 8K encoding. We would have to use at least HEVC. Depending on what you're delivering to, you can also explore VP9 or AV1. I think VVC is going to be very promising for 8K encodes, although it's a ways out. We're doing a lot of research into it now. But in terms of latency, it really shouldn't impact, the resolution really theoretically shouldn't impact the latency, right? One of our big value props, like you said, is the ability to scale and take up the necessary resources. So we're still supporting the same real-time encoding, whether it's HD, 4K, or 8K. We'll just use more resources to get it out live in real time. What will slow it down is if you want to use 2pass, which is a quality optimization feature. And basically that's really benchmarking better quality at the same bit rate. So it's not about decreasing bit rates, but it's about improving visual quality via objective quality measurements. That would really be what impacts the latency more so than 8K versus 4K versus HD.
All right, thank you, Sean. For Tim, is Zixi bonding working with different links from different ISP connections?
Yes, absolutely. That's one of the really cool things about that capability, is when you set up the bonding between it's between your Zixi feeder, which is in one of the encoder devices or standalone, and a Zixi broadcaster. You're bonding between basically as many different IP connections as you want to use. So if you're on premise, maybe you have a hardwired connection that's maybe it's cable modem or something to the facility, and then you can bond that with a 4G IP connection, a 4G modem, and then and maybe bond it with another 4G from a different provider. Maybe one's AT&T and one is Verizon. So then what's happening on the bonding is and the bonding can be set up in two different ways. One way is you can try to push all the traffic on one connection, and the other connections are only there for backup. That's useful if you have if you have metered connections that are more expensive. Then you don't want to use those metered connections unless you need to. So that's one way to set up, put all the traffic on one connection, or and then basically fail over to the other connections. Or if you don't have enough bandwidth for all the content that you're trying to push up, then the bonding capability can also just spread the content across all of your IP connections, so that you basically have an aggregate amount of bandwidth available to send the streams up from your from on premise at your feeder to your Zixi broadcaster.
Okay, and another for Tim, is AES or DTLS more prominent? Which has Fubo used?
Okay, I'm not sure exactly what Fubo's using, but let me at least try to explain the difference between the two. So AES is a fixed key content encryption. And so you on the feeding side, you put in your key, on the receiving side, you put in your key, and the content is encrypted between. What DTLS is doing, the best way to think about DTLS is think about HTTPS. What HTTPS is versus HTTP. That's what DTLS is. It's encrypting the session with a not a user entered key, but we actually allocate a key automatically that gets used for that DTLS session, and so everything in the session is encrypted in that case, headers and the content and the transport stream headers and everything. So that's how the two differ. What Fubo might be doing, because we know they're using BiDRM on the back end, is it's possible that they're doing BiDRM based, using the KeyOS encryption prior to coming into prior to being delivered, or Sean, you might be able to answer, are they doing that, are they doing the BiDRM content encryption on your side inside the transcoding?
Yeah, so for us, it happens post transcode.
Okay.
So yeah, we'll transcode package, transcode, encrypt and package.
Okay. So yeah, so prior to hitting Bitmovin, they would either be using our AES content encryption or the DTLS session encryption, or potentially both for the contribution from the content owners into Fubo, and then from Fubo over to Bitmovin.
All right, I think we've got time for one more question, and that is, how do we use Zixi with Bitmovin? So maybe we start with Sean. How would a Zixi user set up with Bitmovin? And then Tim, maybe a little bit of details on the Zixi end.
Right. I did want to present something like that, but it gets very technical because our configurations are all done via API in, you know, multi-language. So I had a script put together, a Python script, but basically you have to call you have to call particular functions and configure the encoder to actually utilize the Zixi broadcaster. You can't just send a Zixi source and then, you know, expect the encoder to receive it. So there's a little bit of manual work done. We have actually very well documented. We have well documented API documentation on our Git repo with examples of spinning up a live stream with Zixi. And if it's not there, we could upload one there after this, but I'm 90% sure it is. If you want to follow up, I think we have some emails. I could send you an example of how you would configure it, but there's really nothing. It's nothing too time consuming, but it's a matter of editing your script in order to configure the stream to use the Zixi broadcaster before sending us the feed.
Okay, I can maybe jump in on this. So once you've configured the Zixi broadcaster ingest on the Bitmovin side, then on the contribution side, you either need to use an encoder that already has Zixi built in, and you'll basically put in an IP address and a port and a stream name in the UI for that encoder in the Zixi page of the UI, and that's just telling the encoder where to send that Zixi stream to, or if you don't have a Zixi enabled encoder, you can download our Zixi feeder software. So it's free. We don't charge anything. You go to our website and get to a download, and you can download that. And then at that point, what you'll do is on your local network, you'll send either like a UDP or RTMP stream from your existing encoder to the Zixi feeder. And then inside the Zixi feeder UI, you'll configure it to push that stream up to Bitmovin, and same thing. Basically what you need is the IP address and the port and the stream name, and then that's how you would set up that local workflow. And then of course, like we mentioned before, if you happen to be using Media Connect to ingest Zixi and deliver Zixi, you can also take Zixi streams out of Media Connect over to Bitmovin. As well as our mobile apps, for that is, for just to take basically the camera feed off your phone through the Zixi on-air mobile app, and then push that up to Bitmovin for transcoding.
All right, thank you, Tim. Thank you, Sean. I will answer one last question that came in before we sign off. We're a little past the hour here, but somebody asked, in the slides, you referenced AWS and Google Cloud as providers. Why not Microsoft Azure? In these specific workflow examples, those are who the customers had chosen to use, but all three are interchangeable and can be leveraged with our software.
Yeah, and same with the Bitmovin platform.
So we'd like to thank everybody for their participation today. We really appreciate your attention for the hour. We will be sending this out, and for anybody's question that we didn't get to, we do have them logged, and you will receive a personal follow-up. So we appreciate the interest, and we look forward to speaking with everybody soon. Thank you.
Okay, thanks everyone.
Thanks, guys.